Today we're going to be talking about plotting and converting polar coordinates. So what we're used to plotting is we're used to plotting points in what we call the rectangular plane. And just remember, the rectangular plane is the y-axis and the x-axis. Now we're going to come up with a new type of plotting points, and that's going to be the polar plane. And the polar plane, I kind of think it looks something like the unit circle, but you have a bunch of rings and you have a bunch of angles that are coming out. And the point that we're going to be talking about is r and then theta, where r is standing for the radius, or the number of rungs you go out to get to the point. And then theta is going to be the angle that you rotate. So think of trigonometry. That's what you want to think of. So what you're going to do first is your steps to plotting polar points. The first thing you want to do is rotate to the angle. And then move out. The number of rings of the radius. So thinking of this point that I have here, first figure out what your scale is, because everyone's going to be different. I like this polar grid, so this is the one I'm going to be using. From 0, remember from trigonometry, to 90 degrees, divide that up equally into all of these pieces. With 1, 2, 3, 4, 5. I have 6 units, so 90 divided by 6, that's going to be 15. So each one of these is standing for 15 degrees. So this point right here would be 75 degrees, because I rotate up 75 degrees. So the theta would be 75, and let's put a little degree symbol so we know it's degrees. And then you go out 1, 2, 3, 4, 5 rings. Now there's another way to name that point. I'm going to go through and I'm going to continue labeling my angles here. 120, 135, 150, 165, it's 240. 25, 35, yeah, that's 240. So you recognize, just recognize that there's some angles that are common to our unit circle. This guy's 270, 255. The reason that I wanted to keep going through is there's another way to name those points. See this line that 75 degree is on. That whole line, you can think of this point a few different ways. Because if I rotate over to the angle of 255, because that's on that same line, so if I rotate to 255 degrees, but instead of going towards that angle, I go away from it, that would be a negative 5. So your negative radius happens when you go away from the angle that you've rotated to. And that's important to keep in mind. Okay, what I have here is I just have some other polar grids that you might see. So make sure that you understand that I'm just using one type, but there's multiple types of polar grids out there. Okay, so 2 and 30. Again, I like to use this same grid. So this is 0, this is 15, this is 30. So I rotate up to my angle of 30, so it's somewhere along that line. Now 2 is positive, so I go out 1, 2 rungs. So that's that point. Now there's another way that I can name that point. Again, if you think of this whole line there, okay, that angle over in quadrant 3 is the same as 210 degrees. Now that's 210 degrees. I can name this point that we just plotted another way by giving us a negative radius if I rotate to 210 degrees. I can also have 2 being positive, and 2, the radius being positive, I rotate a negative 330 degrees, because 330 is coterminal with 30. I can also have a negative 2 if I rotate to the negative angle of negative 150. So I have a negative angle that I rotate to, but then I don't go towards where that terminal side is. I go away from the terminal side. Okay, negative 240. This is 0. This is negative 180 because we rotate negative clockwise. So this is negative 210, negative 225, and negative 240. So it's on this line, either this one up here or the one down in the third quadrant. But I have a negative angle, so that's where my angle is, but a negative radius. So I don't go towards that angle, I go away from it. 1, 2, 3 units. Now another way that I can name that. I can name that using a positive 3. And if I rotate down, negative, what would that be? That would be negative 60 degrees. If you have a positive 3, but now I rotate from 0 in a positive angle, that terminal side is at 300 degrees. I could also have negative 3 for my radius, but rotating positive for my angle, that's going to be 120. So there's technically an infinite amount of ways to name angles, to name points, because I could add 360 to that. I could add 360 to the angles, because you rotate coterminally. Okay, converting back and forth. So this point right here has some r and some theta. Now how do I convert it back to something that we know? Let's look at drawing a triangle. I need to find the x distance. I need to find the y distance. Well, this is theta. Let's think about that. And this is r. The cosine, let's do cosine. The cosine of theta is going to equal adjacent over r. So that's x over r. So to get the x coordinate, that's just x. I'm sorry, that's r. If I cross multiply both sides by r cosine of the angle. That gets us our x coordinate. Similarly now with y. The sine of theta is equal to opposite over hypotenuse, y over r. So now, to get the y-coordinate, that's r times the sine of theta. And that should look familiar, because on our unit circle, y stood for the sine, x stood for cosine, just our radius was positive. Now, converting rectangular coordinates to polar coordinates. So I have that point there. I have a certain x value, a certain y value. I need to get the radius, that length. That's easy. R squared is equal to x squared plus y squared. And then I need to get this theta. Well, what do I know? I know y over x is the tangent value, tangent of theta, is equal to y over x. And then you're going to have to do some adjusting depending on what quadrant you're in, but I'll go through an explanation of that. Okay, so convert that point to 150 to rectangular coordinates. Remember your formula. X equals r cosine, because cosine is standing for the x-coordinate on our unit circle. So x equals -2 times the cosine of 150 degrees. So x is going to be equal to 1.73. Y equals r sine theta. So y is equal to -2 times the sine of 150 degrees. So y is going to equal -1. So we now have our point 1.73, comma, -1. Next example, converting that. So again, x is going to equal r times the cosine of theta. So I have my radius, which is 3, times the cosine of 250 degrees. And again, that's calculator work. -1.03. Now y is equal to r times the sine of theta. So y is equal to 3 times the sine of 250 degrees. So y is equal to -2.82. So that's just plugging and chugging into the formulas. Find the polar coordinates for point E, which is at the point of 2, -4. So let's plot that so that we have an idea of what it looks like. That's in quadrant 4. So I have 1, 2, 1, 2, 3, 4. So that's my point. Now, let's draw in our triangle. Okay, so this is -4. This is going to be 2. I need to find r, which is the theta, which is the hypotenuse of that right triangle. So r squared is 2 squared plus -4 squared. R squared ends up being 20. So r is the square root of 20, or 2 root 5. Now I need to find theta. The tangent of theta is equal to, this is my theta, y over x. So -4 over 2. Remember, in your calculator, you're doing that inverse tangent of -4 over 2. So then I do that in my calculator. And when I do that in my calculator, we get -63.44. So my coordinates are 2 root 5 radius, and then the theta If you think about it, if you rotate down the negative angle, that puts me at the right terminal side, and then I went out positive for my radius, so that makes sense. Negative 63.44. Next example, find the polar coordinates for this guy. We're in quadrant 3, so this one's going to be a little bit more challenging. Okay, I just want to plot the point because I think that that's going to help us in finding everything we need to find. So we need to find the length of that radius. So let's see what we have here. This is negative 12. This is negative 8. So r squared, the hypotenuse, is negative 8 squared plus a negative 12 squared. When I add those together, I get r squared equal to 208. So that simplifies when I square root to 4 root 13. So that's my r. Now the theta. The theta gets a little bit more complicated. Let's call this theta. Really, I'm rotating from 0 over there. So once I get that theta, I'm going to add 180 degrees to it. So to get that angle, we do r. Tangent of theta is 12 over 8. So when I do that in my calculator, when I do my inverse tangent of 12 over 8 in my calculator, that gets me on theta, remember, that is 56.31. Now that's what this angle is, 56.31. The calculator needs you to give the whole angle. So we need to add 180 to that because I'm down in quadrant 3. When I add 180 to that, I get 236.31. So that's my point. Now let's make sure this makes sense. It does, because I rotate my 236 degrees and I go out my radius to get our point right there. Yeah, there's other ways to get the points, but this is the easiest one, the easiest way to teach it to you guys. There are your lesson questions for the day. Please make sure those 3 questions are submitted on time.